Hello everyone. Our project is zero-shot multi-agent visual question answering system. Traditional large visual language models often fail to accurately count objects, detect small or hidden items, or read text from the images and videos. They also need costly fine-tuning and perform poorly outside their training data. To address this, we built a multi-agent visual question answering system. Instead of relying on a big model, we used multiple specialized AI agents that work together, one for detecting objects, one for counting, and one for text extraction. All these agents collaborate under a large language model like Gemini, which combines their outputs to produce the final and more accurate answer. Coming to our workflow, the user uploads an image or a video along with a question. Our large language model, Gemini, gives an initial answer with a confidence score. If the confidence is high enough, the answer is displayed. If it is low, the system triggers a clip count and a grounding SAM for deeper visual analysis. The results are passed back to Gemini, which refines the final answer with visual highlights for explainability. Coming to our tech stack, we used plain HTML, CSS, and JavaScript for the front end. As for the backend, we are using Fast API to handle API communication. For visual tasks, we used clip count, grounding SAM, and OpenCV, while Gemini API handles reasoning and visual response generation. Coming to our architecture and logic, at the core, an orchestrator manages communication between all agents. It passes a shared JSON context that keeps track of reasoning and visual data. Rule-based logic decides which agent to activate. For example, counting triggers clip count, and text questions trigger OCR. System overview and feature work. Our web interface lets user upload an image or a video, asks a question, view view not just the answer but the chain of thought, showing how each agent. In the future, we aim to make the system domain specific like medical or traffic VQA and integrate more advanced models to improve accuracy and performance. So this is the dashboard of our project. As you can see, there are multiple modes in which auto represents our pipeline. Let's take an example. Let's take an image with a orange and ask the question of the orange in the image. As you can see in the terminal, our pipeline is getting executed as it is in the auto mode. As you can see, the our large language director tried to answer. As you can see, the answer is level is low. So the click of we come into action and gives the response. As you can see, photo is the response. Let's go with another example. Let's take an example of a video of a picture handling three cameras. Okay, cameras frozen in the image in the video. As you can see, again our pipeline is getting executed. Now again our large language model will try to answer the question directly. If the confidence is low, then count of the comments and we take action. As you can see, the LLM is directly giving the answer. Let's go with the clip count for another example. Let's take another video which contains queries in it and try to ask the model to count them. Count the queries. As you can see, the clip count is directly down the option. And across all the frames, 20 is the most frequently required one. We repeat it. So the answer is 20. We are keeping all the models in different modes so that we can access them whichever according to our requirement. As the as we are using Gemini API for the LLM, it mostly gives the correct answer. So we cannot see the clipboard or the things and coming into action. So to see how they are working, we keep them in a separate link. In summary, our project shows how combining multiple specialized AI agents in a modular zero-shot pipeline can greatly improve both accuracy and explainability in visual person understanding tasks. Thank you.